Hello, thank you. So my name is Alex Bilbie, and I hail from London. I've been a developer and a DevOps consultant for about 10 years now, and I've worked across startups and academia and government and enterprise and all manner of companies, big and small. I started off as a back-end developer, as a PHP developer, and over my career I've kind of got really interested into DevOps and also into Amazon Web Services in particular, and I've specialized particularly in AWS and DevOps consulting. I'm currently the head of engineering at a startup in London called Popsa, and we're actually hiring engineering roles in London, so if what I have to say today is of interest to you and you're looking for a job, please do come and talk to me. Some of you may know me from my days involved with the League of Extraordinary Packages. I was one of the founders, along with Frank de Jonge and Phil Sturgeon and Kayla Daniels and a few others. And you may be familiar with some of our packages, such as Climate or the CSV or Fractal. For me, my package was the League OAuth2 server, which powers Laravel Passport, which I'm sure some of you have got some experience with. And Frank de Jonge, who's here in the audience somewhere, he created Fly System, which powers Illuminate file system. And if you're interested in some of the work that we've done over the years, our website is thephpleague.com and github.com/thephpleague. So my talk today is about 12-factor applications. 12-factor apps is a methodology that came out of Heroku in around 2012. And it was written by some of their internal engineers, kind of like as a best practice Bible on how to deploy internal software as well as deploy the customer's software as well. For me, ultimately, I'm interested in building sustainable businesses, and that comes from sustainable software. And I believe the 12-factor application methodology fits in really nicely and can help achieve that. So this talk is going to cover the 12-factor apps, methodology, and it's interspersed with some of my own experiences and opinions on how to deploy software. So of course this can easily apply through to Laravel itself. 12-factor applications is principally written around for like SaaS-based software, but I do think if you come from an agency background, you could perhaps take some of these ideas and concepts back to your work you do with clients in an agency role. I've given this talk before in London a few months ago, and a few people found some of what I've got to say a little bit controversial, so that's fine. Everyone has their own opinions. I'm just recounting my own experiences, and I think you should pick and choose what works best for you in your own situations and companies. So the first factor is all about code base. So every application is going to have a code base, and the 12-factor methodology says that you should have that in a source control. And one of its diktats is that there must be one code base for one application. GitHub now has unlimited private repositories, so let's make use of them. I once worked with a client who had about 50-odd WordPress installations in one Git repository, which caused no end of problems, as you can imagine. It's so easy these days and so cheap as well to split things out, so you really should. Lots of people, when I give this talk or give this as a workshop, ask about Git branching strategy, and my kind of general approach to it is whatever works best for you, whether you use Git flow or you have some sort of other branching model. I write a lot of Golang these days, and Go's approach is basically shove it all on the main branch, on the master branch. So use whatever works best for you. I don't know who said this quote. If it doesn't exist in source control, it doesn't exist at all. But it seems like a sensible quote to live by for me. You're more likely to lose data than GitHub is, so put it in source control, whatever it is. I've kind of got my own quote, which I've come up with this year, which is basically, if it only exists in production, it doesn't exist at all. So we're going to cover this a little bit later on, but I've seen too many setups where the production setup is slightly different on each server because they've all been hand configured, and if you wanted to start from scratch and recreate it and try and implement some sort of best practice where things are automatically created and deployed, that would be a real pain to recreate. Factor 2 is all about dependencies. So pretty much every application has some sort of dependency that's required in order for it to run correctly. It could be a library that's imported, such as Fly System or the OAuth2 League package, or it could be a system dependency like curl or ImageMagick. So a 12-factor app never assumes a dependency is pre-installed in the system, so we always use tooling to try and bake it in to the code base using some sort of dependency tooling, such as Composer in PHP's case, or we'll use another tool to actually bake it into your system image that your code is running on your server. So Composer isn't just for third-party packages. There's no reason why you can't split out your own code, such as your Eloquent packages, into its own model repository and then import that. You might find you're sharing these models across multiple code bases, so you split it out into its own package. It's really simple. You might have a designer or an agency you're working with who's doing some design work for you, and you just want to give them access to the Blade templates rather than all the business logic and mission-critical stuff. So you can split those into your own packages as well. And likewise, one thing I am a firm believer is you should always keep your migrations separate from your application. This is because quite often you want to be able to run your migrations separate to the rest of your code base, and we'll kind of cover that a little bit later on. This is somewhat of a controversial point, but I believe you should git commit your vendor directory. Basically, don't rely on Packagist or NPM or RubyGems or CocoaPods or anything else to ever be up. They go down more often than you think they do. The net result of this, there's a net result of this is basically you get faster build times because you've got everything already in the code base. You could just git clone it, which admittedly might be a little bit slower first time round, but everything's there. You don't need to then hit the network up to download something, and that network might not be operational. Another caveat of this is PR diffs can be a little bit harder to implement. However, there are ways around that, and if you come and find me later, I'll talk about some strategies we use to implement that. So, as I said, you should always bake your system libraries in alongside your application, whether that's some sort of like Docker image, or it might also be Composer requirements, like global Composer or NPM requirements you need as well. They should always be baked into your server image or your Docker image, so that, again, your application is never making any assumptions that they're it's never going to fail because it's making an assumption that something's there that isn't there. You should also make sure you always vendor lock your system dependencies as well. This will give you reproducible builds, and it's much easier to upgrade components. So if you're using a particular version of ImageMagick and then you want to go for the farcical steps that I went to the other day to try and support Apple's Hive format, it's easier then to switch between going from like version 7 to version 8 of ImageMagick and get it to work, and then downgrading because you've wasted an entire afternoon trying to get it to work. If you're not using Docker, but you are deploying to server somewhere, there's a tool called Packer by HashiCorp, which I highly recommend you have a look into. It's basically you define your system configuration using YAML, and then you can use Chef or Puppet or Bash scripts or anything else to then provision your servers. And I really recommend you have a look into that tool. The next factor is all about configuration. So along with dependencies, pretty much all software requires some sort of configuration to go along with it. So this could be some sort of SDK credentials, such as your Stripe keys. It could be database connection details, or the environment domain name, so staging.yourapp.com or production.yourapp.com. And these configurations likely change between environments. 12-factor apps says that you should always keep your configuration strictly away from your code base. The idea being that your configuration can change, but the code doesn't. And if you implement this correctly, it means that it's trivial then to run your application in multiple environments by simply just switching out different environment variables. In my opinion, the .env file that Laravel uses, and admittedly some other frameworks as well, can be considered harmful. I've seen instances where it's accidentally got committed to Git, so to GitHub even, and then people have lost thousands of dollars because some script kiddie found their AWS credentials and then started hammering their servers mining Bitcoin. It's just not worth it. There are better ways of setting up configuration, both for local development and also on your servers, without having to SSH into the server and then manually configuring your .env file by hand. So how do you do that? Well, you make use of environment variables. So the simplest way of doing this in a correct and secure way is you store your configuration encrypted in some sort of cloud storage. That might be S3 or cloud files or something like that. You then, as part of your deployment process, download your configuration variables, and then for each variable in that configuration, you export them into your application runtime environment, and then you can run your app. So, quick code example. So in this bash script that might be part of your deployment process, you're using the AWS command line here to download a configuration variable from S3. And then on the next line, you're splitting that configuration variable up and then chopping it into the environment and then running PHP FPM. And then all of your application environment variables are then running in the PHP FPM process, which itself is running your code. I wouldn't recommend you put any sort of application environment in Nginx, mainly because it's very easy to get your Nginx configuration or your Apache configuration wrong, and then that can lead to crashes. And also, there have been cases where in the past, I think it was Nginx, accidentally was leaking environment variables. So you want to try and keep your configuration as close to your code as possible. There are some better solutions. So if you're running on AWS, there's a service called SSM, which has parameter store as an internal service of that. It's free to use, it's super simple to integrate, and also works with KMS, which can encrypt your environment variables for you for compliance. Or there's a new AWS Secrets Manager as well. If you're running on Kubernetes, there's Kubernetes Secrets, or you can use another tool by HashiCorp called Vault. Or, for example, if you're running on Heroku command line, you can set environment variables using the command line there under the Heroku config section of that command line tool. And then when you're inside your application, so here we've got the database.php file in the configuration directory in Laravel. The Laravel environment helper, the .env function, will automatically pick them up if a .env file isn't present. And in fact, I actually think it checks for environment first before looking for an env, which is even better. If you are running on AWS, for local development, you want one IAM user that has got the absolute minimal set of permissions possible. So if you're storing like user images, for example, in S3, you just want the S3 put object permission. You don't want any of the permissions. Again, you don't want to leak anything into the environment or accidentally give someone malicious access to your full AWS account. If you're running your code then on EC2 instances, you should make use of IAM roles. They will automatically rotate your credentials. You don't need to bake any keys of any sort into any configuration environment variables. And also never use the root account either. It's just for billing. So set a long password on it and then forget it. The next factor is called backing services. So anything your code talks to over the network, such as database or Stripe or Memcache or SQS or the Facebook API, 12-Factor Apps describes these as backing services, and you should always treat your backing services as attached resources. So just like a USB hard drive being plugged into your laptop, these are, you should treat them as like its own separate thing, and you should make no assumptions about how to access resources apart from through your configuration. There should also be no distinction between your first-party services and a third-party service. So, for example, if you're using MySQL locally, you should also use MySQL, if you're using MySQL in production, you should also use MySQL locally on your laptop, however you want to run that on your laptop. Likewise, you should, if you're using, for example, SQS as a queue management server, or as a queue server or service, you can run that yourself locally on your laptop as well. So, how's the best way of doing this? Well, it goes back to configuration again on factor 3. So your app shouldn't care if your database connection string looks like this or it looks like this. And likewise, if you're using Stripe, for example, there should be no difference in how your application behaves, whether the Stripe key is this or your Stripe key is that. OK, next factor. dev-prod parity. So hands up if you've ever experienced a case where it worked on your laptop, but it didn't work in production. Pretty much everyone's had it at some point. So 99% of the time, this is down to environment, like the environment runtime, as opposed to, it's very rarely it's ever specifically about code. It's all about environment. So again, if you're using PHP 7.2.9 in production, make sure that's the same version you're running in your laptop. It reduces the chance there's any differentiation between the two setups. Likewise, MySQL in production, use MySQL on your laptop. Again, SQS. So if you haven't already looked at Docker, I highly recommend looking at Docker. There are hundreds of really good tutorials out there now. Chris Vidal's got a really good series called Shipping Docker. And using Docker and Docker Compose and some of the other Docker tooling, you can run MySQL, FPM, Nginx, Redis, fake SQS all on your laptop with trivially, and it will do a better job of simulating your environment than, say, Homestead ever will. So Homestead is not indicative of your production environment. It's not necessarily configured for performance or security, and your server certainly won't be set up the same, more than likely. Again, you might be running, I don't know what Homestead uses internally, I presume it's Ubuntu, but your servers, for example, that you've been given access to on shared hosting might be Debian or CentOS or something like that. There are, of course, some acceptable exceptions to that. So, for example, in production, everything is highly available. So it might be, rather than running one MySQL instance, you're running multiple MySQL instances to be highly available. And obviously, you've got your environment configuration is different as well. Use your production Docker containers when you do make the switch to also run any sort of continuous integration or even your unit tests as well, because again, you're getting a better representation of how your code is going to run in production. And if you can fix those bugs before that your customers experience them, then that's better for them and for you. So code goes through 3 state changes. The build stage transforms raw code into some sort of runnable application. Then the release stage combines your runnable application you built in the build stage with your configuration that you've set up, however that might be set up. And then the run stage does exactly what it says in the tin. So 12-factor out says there should never be any code changes at runtime. And again, this goes back to my quote I had before. If it only exists in production, it doesn't exist at all. Your server shouldn't know what Composer or NPM is, and you can avoid temptation fairly easily by removing your SSH keys, both on the server and locally. Just don't tinker in production, it'll be easier. I consulted a company once where they were basically doing an NPM install as part of the deployment process on each individual server, and they were running, let's say, 20 instances. And then they were all in turn as we're doing a rolling change, running npm install. And we started noticing basically these little changes. Sometimes it worked every time when we did deployment. Sometimes, though, a certain percentage of the servers were configured ever so slightly differently. And it turned out to be a sub dependency of a really popular package that was being frequently changed because it was using automatic code generation tooling and such. And basically, let's say, we're doing this deployment on 20 servers, and then it got to server 15, and then this package just happened to change at that time. So those last few servers got a different version of the package. And essentially what we ended up doing was A/B testing which customers got a working site and which customers didn't. So you want to make sure that you're doing any sort of compilation like that either on your own laptop or using some sort of build tool. And again, third-party services are unreliable, and the last thing you want is you're deploying an emergency fix and then GitHub goes down, and because it will always fail at the worst possible moment. So the build step, you would normally have some sort of installation script like this. Ideally, this would be run as part of some sort of continuous integration tool like Jenkins or Circle CI or Travis or anything like that. And the first step you always want to do is fetch your dependencies. And then you're going to compile the application, and this might be one step, it might be multiple steps. Preferably, the best way you can do this is you implement each of these steps in a multi-stage Docker build file. Again, you can find some quite good tutorials on how to do this online. But basically, that means that both your developers in your team or yourself, but also your continuous integration server are all using the exact same method of running each of these commands. And then finally, once you've compiled your code, you've done any other sort of tweaking you want to do to it, you're going to push it. So this is an example, a really simple working example of how you could push your Docker image that you've just built, for example, up to your Docker image server. Or it could be creating a zip file and pushing it into some sort of cloud storage for deployment later on. If you are using Docker, don't use the latest Docker tag. The reason being is that the latest Docker tag gets cached, a Docker tag will get cached, and if you're continuing to compile each new version of your code into your Docker image, into the same Docker image with the same tag, for example, latest, it will get cached by each server. And so when you think you're doing a Docker deployment, and you're saying deploy this version at tag latest, it won't necessarily get deployed because those layers have all been cached. And this gets especially annoying if you've thrown away your SSH key because you then can't go in and clear your Docker cache. So make sure you always increment your tag numbers or any other sort of number, whether it's a zip file or Docker. If you are, again, another trick if you're using Docker, make use of a Docker base image. So it might be, for example, that you have one Docker image that all it has is PHP installed and then any other system dependencies like ImageMagick or curl. And that way, you import that image into your image where your code gets bundled in. And then when it comes to deployment, that base image will be cached. And all it will need to do is on deployment is just download the next it would just need to download the code layer rather than the base layer, which would be a lot faster for deployment. And then finally, the release stage, which is all about combining code with configuration. So that might be downloading some configuration, exposing it, and then part of a Kubernetes pod or an ECS task if you're running on AWS. Every release, as I said, should have a unique incrementing ID so that it can be identified, and that incrementing ID could also be like a Git tag, for example, or a Git hash as well. Once a release has then been created, it can't be changed. You need to create a new release. Again, because then you don't end up with any sort of scenario where you've got tagged this, which has been deployed to half your servers, and then you've tagged it again because you've realized you missed something, and you redeploy that. You won't end up with any disparity between your instances. And then the run stage, so deploying a release. So this is all about telling whatever orchestrator you've got, such as a Docker orchestrator like Kubernetes or ECS, or it could be running Chef or Capistrano. You want to make sure this step is as simple as possible because any good orchestration tool, if it notices that your server crashes or a new server spins up as a result of some sort of auto-scaling action, it will do that deployment for you automatically, and you just want it to be as simple as possible so it's as reliable as possible. Make sure you document how to build, release, and run your software. This can help prevent hit by bust scenario whereby there's only one developer on your team who knows actually how to do these deployments. And also, it's easier to spot where the manual bits are and how you can add automation to this over time, which will just improve your workflow and, again, simplifies it for new developers joining your team who want to deploy code into production on their first day. You should also write a release plan as well for every release, especially if you know that, for example, there's going to be a database migration, then whichever ops engineer is doing your deployment, they might need to run that migration before they do the code, deployment. So it's always good to write a release plan as well. Okay, processes. So processes is all about the running of your application. So the way 12-factor apps, if you read the manual, describes this. It normally considers an app to be a single binary of some sort. However, in the PHP context, we can consider this to be your code base associated with or running alongside PHP FPM. So that's one process there, or one application even. Again, using Docker will make this much easier. So it dictates that your application, so again, in this context, PHP FPM with your code should do one thing and one thing only. So no running PHP FPM and Nginx and supervisor D in one container. Split them out into separate containers. It'll make deployment easier. You can better manage your dependencies, and you could swap components in and out much, much more easily. So again, if you're new to Docker, then this is one example here of how you can be running 2 instances of your code base alongside an artisan queue listener as well, all with one code base. So it's one Docker image just running in slightly different variations with different runtime commands. Again, your app should be stateless, it should be stateless. The last thing you want is that you do some sort of deployment or your web server dies and all your users are logged out. Hands up anyone who thinks if their server crashed today, they might lose some sort of data, whether that's user images or like PHP sessions, for example. Okay, a few hands, but lots of guilty faces. Any data that needs persisting must be away in a stateful service. So, for example, you might want to upload your user images to Amazon S3 or Google Cloud Storage or somewhere like that. Again, the Laravel Illuminate fly system integration makes this super easy. And you should also store PHP sessions, which are often forgot about elsewhere as well. If you use the PHP extensions, for example, Memcache or Redis, you can run PHP sessions directly through there. There's a DynamoDB library that makes it really simple. Or even better, just get them completely out of any sort of stateful storage and just store them locally on your user's computer through cookies or JWTs in some sort of storage through the browser. Sticky sessions is another section in the 12-factor app manual. They're considered harmful basically because it then ties some sort of session or some sort of user activity to a particular instance. And again, if that instance then goes away, that user's then stuck for whatever reason. So it could be they're logged out or their in-transit image upload is then lost. So never assume that anything is going to stick around. In my experience at scale, I've seen MySQL and Postgre, for that matter as well, really crap out as a queue driver. When you're pumping through millions and millions of queue jobs, it just doesn't do locking correctly. I'd really recommend you instead look at something like SQS, which does it properly hands out messages and then immediately makes them invisible to all other instances of your queue workers. It's really cheap. You can do first in, first out queues. It's something like 40 US cents per million jobs that are in the system. And it's zero management as well. I'd also say if you care about your data, use managed database hosting. Running your own MySQL database instance or Postgre or whatever it is you use can be really difficult. You need to then implement your own backup and restore processes. In my opinion, for as cheap as $20, for example, with AWS RDS, just let them handle it. They've got battle-tested backup and restore processes, and it's one less thing for you to have to worry about, because at the end of the day, time really is money. And if at 3 a.m. you've run out of storage on your database, and you then need to quickly do something with it, you can then quickly increase the size of it rather than having to go into DigitalOcean and SSHing in and then trying to find what the problem is, reading the logs, etc. Just get someone else to do it for you. Again, they'll always do a better job of looking after your data than you will. This factor is a little bit tricky to put in the context of PHP. Again, what it's trying to describe is basically that your application should only expose one port. So in the context of PHP, traditionally it would be embedded as part of a fast CGI process in Apache. But 12-factor apps dictate an app must be completely self-contained. So as we mentioned before, PHP FPM and your code base can be considered one running application in the context of this talk. And PHP FPM will just be listening on a single port, a single server port, which traditionally is 9,000. So in this example here, we've got FPM listing on port 9,000 alongside the code base, which is bundled in, and then Nginx sits in front of the sits in front, whether that's on a separate server, whether it's on the same server, but either way, it's a separate running process. Docker, you can trivially set this up with Docker as well. In any case, Nginx is listing on port 80, and then your load balancer, again, that might be HA proxy or EC2 load balancers, is then sitting in front of that 443 and doing like SSL termination, things like that. But anyway, it would probably distribute your incoming requests across the application. And this sort of setup results in you being able to trivially scale your application up and down as demand on the service increases and decreases. Alternatively, this is another way you could host your client sites if you're in an agency setup. Again, just running lots of Docker images which contain your individual clients' code bases alongside FPM, and then just putting Nginx in front of it. I've seen at more than one company, unfortunately, PHP Artisan Serve being used as the web service. Just don't do it. It's not suitable for production, no matter what anyone will tell you. Concurrency is something like the 10th factor. I'm losing track now. I should have written some numbers down. But concurrency is basically about doing things, more than one thing at the same time. So in other languages, we'd probably be talking about threading here. But again, PHP, we can kind of go back to this diagram here. It's all about scaling out. So, too many. Using some sort of orchestration tools such as Kubernetes or AWS ECS, if you are looking at Docker, will help this happen really easily for you. It will make this much easier to manage. And again, you can set up some sort of auto-scaling rules so that as your application receives lots of requests during the working day, it will scale out to make sure your requests are really quick for your users. But then, on the other hand, at night time, they'll scale down. This will keep your finance department really happy because you're not paying for servers you're not using. The other reason why you want to split things out like this is because there's no PID files. So everything is daemonized and running in its own layer. This means that, let's say, you have a set where you've got an auto-scaling group, you've got lots of instances running your application, but then it comes to 6 p.m. and people are starting to leave the office and your application wants to scale down. The operating system can then, that's running your Docker orchestrator or whatever orchestration process you're using, will then gracefully shut things down and will make sure there's no like transient data that's suddenly lost in state because you're just terminating things like that. It can also help with streaming logs as well, which we'll talk about shortly. If you are building your own Docker images, the default PHP FPM configuration is not suitable for Docker, for running in Docker, because it's not correctly daemonized and the log output isn't going in the right place. So I'd recommend you just use the pre-built one for you in whatever flavor you want to run it in. Disposability is all about scaling quickly, both up and down. And when you have code that is not modified at startup, that automatically has its environment baked in, and you're making use of Docker layer caching and automatic environment configuration, then your orchestration tooling can make this a dream for you, and you don't have to essentially touch it anymore. Alongside disposability, code is disposable, obviously, but servers are disposable too. Servers shouldn't have names. Servers are not pets. Servers are cattle. I appreciate this is not a vegetarian-friendly statement, but pet servers, i.e. servers that have names, are hand-managed and they're looked after and they're fed over time, and they basically become systems that are frail and relied upon, and then inevitably they go down, and then you get a miserable call from your boss who calls you at 4 a.m. because some client can't access some site that no one cares about. You want servers to be automatically built, designed for failure and replaced at a moment's notice. You want to scale up and down as quickly as possible. As I said, if you can scale up and down really quickly, you're then not paying for servers that you're not using, which really does keep your finance team happy. And also your users get the best experience because there's an appropriate amount of load in the system, servers to handle the load in the system. Practice chaos engineering. If you've not heard of this term before, it came out of Netflix, and basically chaos engineering is all about turning off your servers in production. If that sounds scary to you, then you might want to have a look into some of this into 12-factor apps, because if you can be confident that if one of your production servers died at a moment's notice and everything keeps ticking over, your users are being served, your boss isn't aware of it, the fact that it's going down, then everyone's happy and you'll be a happy developer and your operations team will be happier and such. So I would encourage just to, one day go, just delete and see what happens. It's not as scary as it thinks, unless you obviously know that it's going to go down. In which case you should do something about it. Okay, we're almost there. Logs. So logs are there to help us find bugs and understand what is going on. In my experience, the more logging, the better. It's easier to find things. Again, when you start scaling out of more than one server and more than one process, you should really look into some sort of distributed tracing system, because it will then help it'll make finding problems in distributed systems a lot easier. But fundamentally, logs are cheap, and storage is cheap as well. So I encourage you to use this statement as much as you can. Try and make sure your logging is going to standard out and standard error if you're using Docker. If you're not using Docker, then make sure your log files are coming off your servers as quickly as possible. And there are loads of companies that are not expensive out there that can help you do this. Here's just a few, for example. Remember not to log personally identifiable information. I'm sure many of you here have been through some sort of god-awful GDPR compliance process over this year. Just make sure you're not logging people's email addresses, log their user IDs instead. Don't log their addresses. Certainly don't log their credit card numbers. I've seen it happen, and it wasn't fun to fix, because they'd made this logging of their credit card numbers a core part of their application, and what is your alerting solution? So stuff breaks, it will break, assume it's going to break. How are you going to monitor this? Again, farm it out to someone else. People do this better than you will ever do it, better than I will ever do it. So you make use of some sort of third-party service. They've all got quite an extensive free tier if you've not got a lot of cash behind your business and such. But again, if you know something's broken, it's better that you find it out before your client does, and then it keeps everyone happy. And the final factor, so admin processes. Sometimes you do need to run one-off processes. So for example, a migration, or some sort of other one-off task that you've written. You can use the same Docker image that you've previously built for your application to do this, and you can orchestrate it, or you could run it as a one-off task. Again, if you're using Docker, super simple, and using some sort of container service like, orchestration service like ECS or Kubernetes, you just create a one-off task and run it. And again, you can build quite a lot of tooling around this to help you do it. And I got through 103 slides a lot quicker than I thought I would. So yeah, that's my talk. Thank you. Are we doing questions? Oh, no questions? Questions?
Yeah, so I think we can do a couple questions.
Yeah, we've got time.
Do we have the catch box? Would anybody like to ask a question? I can throw this to you. It's fun. You ready? Heads up.
I do appreciate I got through quite a lot of things, so please do come and find me if you
it's coming.
got a question you want to ask later on.
All right, now talk carefully into the microphone next to your mouth.
Oh, it's a microphone.
Yeah.
Cool. Hey, thanks for your talk. Recently, there's been
Can you put it closer to your mouth, please?
Sure. So recently, there's been some controversy about storing secret credentials in environmental variables. Specifically, it's been pointed out by the CSO, the Chief Security Engineer of Docker. Environmental variables, they have potential to be logged and end up in places where they shouldn't. So they were suggesting to use secret information, to put secret information inside files instead. Which you can do with Kubernetes secrets. You can mount secret values as files, right? What do you think about this approach? Do you have a preference?
I think in the case of PHP, and certainly if you're running a quite a high-profile application that's getting tens of thousands of millions of requests, if you're using environment variables versus a file, then one, you're not reading that file on every process on every incoming request, but also you can create some sort of agent fairly quickly that if you do need to swap out an environment variable fairly quickly, you could just basically get your deployment tool to not deploy the code, but just pull down the latest version of your secrets again. I'm not sure about keeping them in a file because, again, files can be harvested off computers and such, and you get problems with permissions and such. I think if you've got dev staging production parity, you'd fairly quickly know if there are any environment variables being logged into anything. So hopefully you catch it there. But personally, I think the context of PHP is better to put them actually into the environment, into the operating system environment, rather than running through a file. That's my personal opinion. But others, everyone has their own way of doing it. This approach that I've described today has worked best in the applications that I've worked on and such.
Thanks.
Okay, so I think maybe we cut to lunch, if that's good.
Sure.
Round of applause for Alex Bilbie.
Thank you.